Hey there guys, welcome to your Unit 2 review. This review will cover everything from number 1 all the way to the end of your review. So make sure you study this before your test, which is on Friday or Monday if you're B-Day. Now notice from numbers 1 through 8, none of the questions number 1 through 8 have an equal sign. And in the direction that says simplify the expressions. For numbers 1 through 8, you are not solving for x. Your answer will not look like x equals 2, x equals negative 5. That only happens 9 through the rest of your review because it says solve the equations and there is an equal sign. So you only get x equals 2 or x equals negative 5 if you see an equal sign. If there are no equal signs, your answers will look like 2x plus 1 or just negative 5x. So let's start with number 1. On number 1, we see that we have 3x minus 5x. This is a combining like terms problem. So your first step is to recognize I have a variable x, and you have to ask yourself, is there another number that also has the variable x? Well, yes. I see I have a negative 5x. It is important to circle the sign in front of it. This is not a 3x and a 5x. This is a 3x and a minus or negative 5x. Since they both have an x, they're considered like terms, and I can combine them. So I can do 3 minus 5, which is negative 2. But keep the x. So 3x minus 5x is negative 2x. Looking at number 2, you may recognize that the 7 also has a y, as well as the negative 2y. So you may want to start combining them. But before you can start combining, we need to get rid of double signs. So this reads as 7y minus negative 2y. We know that a negative and a negative make a positive, so I'm going to turn that into a giant plus sign. So the problem is actually 7y plus 2y. Since the 7y and this 2y both have the same variable, I can combine them. It's combining like terms. 7y plus 2y is 9y. These are your answers for numbers 1 and 2. It's not x equals, it is just negative 2x and just 9y, because the direction told us just to simplify, because these are just expressions. On number 3, I see it's a little bit larger, but you still follow the same steps. Generally, you go in alphabetical order. So I know y in the alphabet goes before z, so I will start by looking at that variable. So I circle my positive 2y, and I say, okay, are there any other numbers that have a y? Well, no. I have a 3z and a z by itself. Since the 2y cannot combine with anything, it is going to be brought down, and it will stay on its own. Now I can look at the z's. So I'm going to square my 3z and square my negative z. Keep in mind, anytime you see a variable by itself, it has an implied 1. So this problem reads for my z's 3z minus 1z. These both can combine because they both have the same variable. I know 3 minus 1 is 2. So 2z. But be careful, do not just leave your answer as 2y, 2z. This is a positive 2z, so I'm going to write plus 2z. These cannot combine. 2y has a y, 2z has a z. They do not have the same variable. So your answer will just stay 2y plus 2z. It can no longer be simplified. For number 4, we have a longer problem, negative 4x minus, in parentheses, negative 2y plus x plus 3z. I see that I have double signs, so I'm going to start there. Double negatives make a positive. I have no other double signs, so I can start combining. Once again, I'm going to start in alphabetical order, so I'm going to start with my x. I have a negative 4x and a positive x by itself. But we already said when an x is by itself, it has an implied 1. So I can combine these since they have the same variable. Negative 4x plus 1 is negative 3x. Next in the alphabet would go y, so I'm going to look at my y. I have a 2y. There is no other number that just has a y, so it's going to stay the same since it does not get added nor subtracted. Finally, I see that I have a 3z. Same thing, there is no other number with just a z variable, so it does not get added or subtracted, so it stays exactly the same. Now I have negative 3x plus 2y plus 3z. Since none of these variables are the same letter, this is my answer as simplified as it can be. For number 5, 6, 7, and 8, these are distribution problems. You know you can distribute when you see parentheses and a number touching it without a plus after the number or a minus. Distribution is just fancy multiplication. So your first step, always when you're distributing, is drawing your double arrows. These arrows mean to multiply. So we know when x is by itself, I have a 1. So 2 times 1 is 2. Keep the x. So 2 times 1x is 2x. Then I'm going to have 2 times, not just 3, negative 3 because of that minus 3. 2 times negative 3 is negative 6. These cannot combine. The 2 has an x to x. The 6 does not have an x. They are not like terms. So your answer will stay as just 2x minus 6. Number 6, we're going to do the same thing. We're going to draw our double arrows. And we're going to do negative 3 times 2x. Well, negative 3 times 2 is negative 6. Keep the x. And negative 3 times positive 2. 3 times 2 is 6. Negative times positive is negative. If you do not remember your multiplication rules, don't forget you can draw your triangle, where you can say, hey, I have a negative 3, positive 2. My answer should be the leftover negative. Once again, these are not like terms, so my answer will stay as negative 6x minus 6. Number 7 and 8 look a little bit more complicated because they have fractions, but it's only one different step. So if you see whole numbers in your distribution, it means multiply. If you see fractions in your distribution, it means to divide. So 1/3 times 6x just means 6 divided by 3. Well, 6 divided by 3 is 2. Keep the x. And negative 3 divided by 3 is negative 1. My answer will stay as such. So do the same thing here. This one is a fraction, so I'm going to be dividing by 2, but it is a negative 2. So I know 4 divided by 2 is 2, and positive and negative will give me negative. So negative 2, keep the x, negative 2x. Negative 1/2 times 8 is just 8 divided by negative 2, which is negative 4. So those are your answers for numbers 1 through 8. So for the rest of the problems, we are now solving for x because they are now equations because they're expressions with equal signs. So in this case, we see that we have 16 equals negative 7 plus x. Our goal is to get the variable by itself. But next to this variable, I see a negative 7. To get it on the other side of the equal sign so that it can combine with the other constant 16, I need to use inverse operations. That is to say, the opposite. I need to undo it. So the opposite of a negative 7 is a positive 7, and what you do to one side, you have to do to the other. So my 7's cancel out. I can bring down my x. 7's cancel out, so I don't bring anything down there. You don't have to write the 0. Equals 16 plus 7, which is 23. So x equals 23, or you can leave your answer as 23 equals x. They mean the same thing. For number 10, our variable is here, but remember this fraction bar means divide. Our variable is being divided by 5. Another way you can look at it is what number divided by 5 is 12. If you know your multiplication facts, you may be able to figure that out, but we're going to solve it algebraically. So I want to get rid of the divide by 5. Well, the inverse of dividing by 5 is multiplying by 5. And what I do to one side, I must do to the other. So my 5's cancel out. I can bring down my a equals 12 times 5, which is 60. So a is equal to 60, which makes sense. 60 divided by 5 is 12. For number 11, I can see that is being added by 2. So to get my variable by itself or isolated, I need to do the opposite of plus 2, which is minus 2. So I get b equals 25 minus 2, which is 23. So b equals 23. For number 12, I say I have negative 8x equals 48. So remember, when a number is touching a variable, it means they are being multiplied. So negative 8x is negative 8 times x. So I'm going to do the opposite of multiplying, which is dividing. Since it's being multiplied by negative 8, I'm going to divide by negative 8 to both sides, which leaves me with x equals 48 divided by negative 8, which is negative 6. Four more problems. We have 13, 14, 15, and 16. So for 13, we are now going on to two-step equations. So numbers 9 through 12 are one-step equations because one thing is happening to my x. It's either just getting divided, just getting multiplied, or just getting added. Here, two things are happening. This reads that's negative 17 equals 10 times x plus 3. So I'm multiplying by 10 and then adding 3 to it. So I'm going to have to undo two operations. So you always undo first the number that's being added or subtracted to your x. In this case, I need to undo this plus 3. The opposite of plus 3 is minus 3. And what I do to one side, I must do to the other. Negative 17 minus 3, be careful, is negative 20 because it gets more negative by 3. Then I can bring down my 10x. So I have negative 20 equals 10x. 10x is 10 times x, so the inverse is divide by 10. So I will do that to both sides. Now x is by itself, and I just have to do negative 20 divided by 10. I know 20 divided by 10 is 2. Negative and positive is negative. So x equals negative 2. For number 14, I have m divided by 4 minus 1 equals 2. So some number, when I divide it by 4 and take 1 away from it, I will get negative 2. Same thing as before, always get rid of the number that's being added or subtracted to your variable first. So I have to get rid of this minus 1. So plus 1 to both sides, which leaves you with m over 4 equals negative 1. Since it's being divided by 4, the inverse of dividing by 4 is multiplying by 4. So these will cancel out, and you are left with m equals negative 4. For number 15, everything's being divided by 6, so we have to get rid of the fraction first. So 15 and 16 are your exceptions. Usually, you have to get rid of the adding and subtracting first, unless everything is being divided by a fraction. So to get rid of that divide by 6, I'm going to do times 6 to cancel it out, and times 6 to the other side, which leaves me with 9x equals negative 36. Because 6 times 6 is 36, negative and positive is negative. To get rid of the 9 times x, I'm going to divide by 9 on both sides and get x equals negative 4. Because negative 36 divided by 9 is negative 4. On 16, I'm going to multiply by 9 on both sides to get rid of that divide by 9. To get 18 is equal to n minus 3. I haven't done anything to the top, so it's going to stay. Last step, get rid of that minus 3, so I'm going to add 3 to both sides. N equals 18 plus 3, which is 21. Or 21 equals n. They mean the same thing. So the first video will just cover the questions on the front of your review. So watch the next video to watch if you need help on questions 18 to 23.